Your brain undergoes a secretive process at 3 a.m., contradicting the belief that this time is simply random. It's a surge in cortisol, the hormone driving wakefulness. Measured cortisol spikes occur 2–3 hours before waking, as confirmed by a 2019 study from Stanford. This timing aligns with your body's circadian rhythm, which orchestrates hormones and body temperature. Inside the adrenal glands, cortisol levels elevate, preparing your body for morning alertness. This mechanism is rarely associated with stress at night, but it's a natural physiological event. The next time you wake at 3 a.m., consider your biological clock ticking. While your body lies seemingly dormant, your brain's neurons are anything but idle. REM sleep, which dominates the later sleep cycles, sparks significant neural activity. This stage is when your brain consolidates memories, integrating information from the day. In a 2007 Harvard study, subjects deprived of REM showed impaired memory recall, emphasizing REM's role. The synapses in your hippocampus, a memory hub, undergo strengthening, welding experiences into long-term storage. Your 3 a.m. awakening might coincide with these high-energy neural processes, not just random restlessness. At 3 a.m., the myth of a complete energy lull is dispelled. Instead, your body is actively managing energy. Core body temperature hits its lowest point during the night, around 3–4 a.m., as discovered in a 1995 study by the University of Chicago. This drop signals your circadian rhythm's effort to conserve energy. With lower temperature, metabolic processes slow, reducing energy expenditure. This natural dip helps realign your internal clock, prepping for the day ahead. It's a finely tuned biological strategy, not a sign of your body failing you. Melatonin, often dubbed the sleep hormone, peaks much earlier than 3 a.m., typically around midnight. By 3 a.m., its levels are declining, as shown in a 2011 research by MIT. This decline is crucial for transitioning towards wakefulness. Melatonin's drop signals your suprachiasmatic nucleus, the brain's master clock, that dawn is approaching. Its receptors in your brain become less active, gradually reducing sleep pressure. This mechanism isn't about disruption, it's a natural prelude to waking. Your 3 a.m. alertness is a testament to your body's precise hormonal choreography. Common belief suggests midnight as peak dream time, but deeper mechanisms say otherwise. The longest REM periods occur closer to morning, around 3–5 a.m., as per a 2008 study from the University of Pennsylvania. This is when vivid dreams peak. Brainwave activity, resembling wakefulness, supports these dreams. The brain stem, through acetylcholine release, fuels this high-frequency activity, crucial for dream generation. Your 3 a.m. awakenings might be your brain concluding a vivid dream cycle, not simply random insomnia. It's your REM architecture in action. Adenosine, a neurotransmitter that accumulates in your brain during wakefulness, plays a key role in sleep pressure. As the night progresses, adenosine levels decrease, facilitating wakefulness. This process is meticulously tracked in a 2020 study by Johns Hopkins. Adenosine binds to receptors, slowing neuronal activity. But by 3 a.m., adenosine clearance is in full swing, shifting the balance towards wakefulness. This molecular dance within your brain isn't just about feeling sleepy or awake. It's a precise biochemical balance that influences your nocturnal awakenings. Inside your brain, the glymphatic system clears metabolic waste during sleep, a process vital for neural health. Activated primarily in deep sleep, this system was highlighted in a 2013 study by the University of Rochester. Cerebrospinal fluid flows through neurons, flushing out toxins like beta-amyloid. By 3 a.m., the glymphatic activity slows, having completed its peak cycle. This reduction might influence your tendency to wake up, as your brain transitions from deep cleaning to lighter REM sleep. It's a nightly detox with profound implications for brain health. At the core of your sleep-wake cycle lie circadian oscillator genes, a biological clockwork keeping time at a cellular level. Genes like clock and BMAL1 regulate daily physiological rhythms. A 2014 study by the Salk Institute revealed how these genes synchronize bodily functions. Around 3 am, these gene expressions help recalibrate your internal clock, subtly preparing you for dawn. This genetic orchestration isn't just theoretical. It underpins how your entire system aligns with environmental cues. Your 3 am wakefulness is a reflection of this genetic ballet. The cortisol awakening response is not an abrupt morning event, but a gradual, orchestrated process. As studied in a 2012 paper from the University of Zurich, cortisol levels begin to rise hours before waking. This surge enhances glucose availability, preparing you for the energy demands of the day. By 3 am, cortisol's subtle increase moves you towards wakefulness, even if it doesn't wake you fully. It's part of a finely tuned endocrine cycle that readies your body well before sunrise. This hormonal prelude is your body's natural alarm system. REM sleep is crucial for emotional regulation and memory consolidation. During REM, the amygdala processes emotional experiences, a mechanism detailed in a 2015 Stanford study. Neurotransmitters like norepinephrine are suppressed, creating a unique brain chemistry. By 3 am, REM cycles are longer, intensifying this emotional processing. This is when your brain weaves emotional threads into the fabric of memory. Your 3 am awakenings might coincide with these vivid processing sessions, as your brain stitches together the emotional tapestry of the day. Chronic sleep debt impacts your brain far beyond occasional 3 am awakenings. This deficit accumulates over time, as shown by a 2016 study from the University of Pennsylvania. After just 1 week of reduced sleep, participants showed cognitive deficits equivalent to 2 nights of total sleep deprivation. Inside your neurons, the buildup of adenosine intensifies, while glymphatic clearance falters, leading to impaired cognitive performance. Your 3 am restlessness might be a symptom of this accumulating debt, a reminder that your brain requires consistent recuperation to function optimally. Tracking apps often promise insights into sleep patterns, yet their reliability is surprisingly inconsistent. A 2018 study by the American Academy of Sleep Medicine found significant discrepancies compared to polysomnography, the gold standard of sleep measurement. Apps often misinterpret movement as wakefulness, missing subtle transitions between sleep stages. While they suggest you wake at 3 am, they can't capture the nuanced interplay of neurochemicals like adenosine or the cortisol cycle. Your 3 am alertness might not be as neatly packaged as an app implies. The wellness industry often promotes blanket solutions for sleep challenges. Yet, peer-reviewed literature paints a more complex picture. A 2020 study by the Journal of Clinical Sleep Medicine critiqued common interventions, like melatonin supplementation, highlighting limited efficacy. Your 3 am awakenings might resist simple fixes, rooted instead in intricate neurobiological rhythms. Inside your brain, precise oscillations of circadian genes and neurotransmitter dynamics defy one-size-fits-all solutions. The real science illuminates a world far more intricate and personalized than mass-market advice suggests. Sleep deprivation, acute or chronic, has profound effects on your brain's physiology. A 2014 study by the University of California, Berkeley, demonstrated that even short-term loss diminishes the amygdala's ability to regulate emotions. The prefrontal cortex, responsible for decision-making, also suffers, impairing your ability to focus and recall information. By 3 am, these deficits might manifest as heightened emotional responses and cognitive disruptions. Your brain's architecture is resilient yet vulnerable, and the cost of ignoring its signals is significant. Reframing your 3 am awakenings involves understanding the complex biology at play. A 2023 study from Oxford University observed that 40% of participants waking at 3 am reported improved daytime focus when not distressed by their nocturnal timings. The findings suggest that awareness of your brain's natural rhythms can alleviate stress associated with these awakenings. Your brain's nocturnal activities are not failures, but finely tuned processes. Understanding this can transform your perception of 3 am wakefulness from an annoyance to an acknowledgement of your body's precision.